Actually, besides cloud computing and edge computing, is there any other computing that can help to improve the performance of manufacturing?
Oh, yeah, of course, there is another one. You want to know more? Let's Sembang AIoT. Hello. Good afternoon, everyone. Very good Friday today, huh?
Yeah.
Okay. How are you today? Good morning, good evening, wherever you are. So, of course, Malaysia is still in the afternoon. So, last week, thank you for watching the Let's Sembang AIoT channel. This is episode number 42. 42, we have gone so far. In fact, some of you who is following us previously, I do share in my personal Facebook also in the live. But then so long already, I didn't I didn't show anything. But at the back, we are still continuing doing this live for the past 8 months already. So how are you today? Yeah, my name is CC Lee.
My name is Sembang.
Yeah, we are constantly doing this live, for this coming every Friday, 4 o'clock. We are still doing this live session. Of course, we talk about AIoT. We sembang about this technology. How can you use the technology to do something beneficial, in your life? Especially in this part, we are talking about industrial world, industrial transformation, digitalization, digital transformation, and so on. Yeah, that is the main thing that we will trying to share. Of course, if you are the first time looking at this panel, our live sharing is usually it's quite spatial, we always come with some demonstration. We always come with a demonstration. Preparing this kind of demonstration is sometimes it's quite exhausting, It's quite exhausting. But due to the fact that we have set up our commitment, to do this live for the 100 session, this is number 42 already, yeah. So that is where we are, and then that's how we are progressing. So I hope you enjoy this channel. Of course, if you find this channel relevant, do like, share, and subscribe. Yeah. So today's actually when Ken Long asked about, what are the computing, because last week I think we talked about what are the things that we talked about last week. We talked about monetization. We talked about how do you data become a commodity? How can you sell your data in future? This road or this kind of what they call the process, it's going to be become realistic in the coming I don't know how long, yeah, because there are some standardization being planted in most of the data set in terms of standardization. I think if those of you who follow us in our last how long ago we share about this data space?
I think
maybe about
quite long already.
About 3 months ago or something like that. International data space. There are some standardization. How can you make use of the standard to monetize your data set? Because why is this data become why people want to why your data become valuable? Why people want to buy your data?
They need the data. When they need the data, they buy your data.
There is a demand in your data, yeah. There is demand in your data, so that's why of course, they want your data for what? Because of the AI, of course. One of them is because of AI, and because of the deep learning AI. Because I just realized we talked about AI. In fact, AI has already been a long time, but deep learning AI is something quite new, I would say, yeah. More practical way of applying AI. This part is deep learning AI. So having talked about this last week we talked about some standardization, how you can acquire data, what are the protocol involved. I think we share some MQTT, AMQP, how can you retrieve your data. And then we talk also about this unified namespace. Yeah, unified namespace is one of the industrial standard using the ISA 95 standard, where data can be, you can exchange your data, with different system platform that most of the enterprises, do require that kind of data actually from the OT side, yeah, operation technology side, factory floor, shop floor, and so on. Yeah, today we come back to, as what Kenong just asked, we were having edge computing. Many times we use in the IoT layer, we have what we call the lower part. Maybe we can share some of this thing here. Yeah, maybe we can share one of the slides. Okay. Okay, so this is our common, what they call IoT architecture. This is our IoT architecture. We have a very low-level sensors, machines, from the machines, and also some you use some standard protocol to acquire or to publish things to your edge layer. What are the missing layer? You see that there's one missing layer part. Before that, I think we don't have that. Yeah, we are we connect direct. Connect direct. You can use a 5G network, a 4G network, or LTE. Of course, LTE is 4G, yeah. So your office network, broadband, internet, and things like that. Published to the cloud and the application level. So, which are the missing part? Yeah, maybe we can move on here. Yeah, so the answer is fog computing. A lot of people, I don't know whether this fog computing thing is very, what we call, it's not very usually heard, but maybe you're already using it. Yeah. For example, in one of the SCADA system, SCADA system by itself, yeah, although it's a centralized, but by itself it can become one of the fog computing platform. Yeah, for example, in this case, fog computing can be what? After gathering all the data, what could be the fog computing function in this case?
After gathering all the data, the fog computing can summarize all the data and then show it like a center. Gather all the data and then show you a summary.
Okay, so that is basically what fog computing is doing, but more precisely is that it gives you a kind of decentralized data management, where although in between you can see it's a centralized, but the function-wise it has to be decentralized. Decentralized meaning it can make certain decision at a different what they call cell or different area, different zone. So there is such thing called a fog node. Of course, fog is in between the cloud and the edge. Edge of the cloud. In between you have fog. What is basically fog? Fog is basically kind of mist in between. So this kind of terminology sometimes is very interesting, but then I think it's clearly indicated that fog is basically acting in between the cloud and the edge. Yeah, and the edge. So most of the thing you can see at this level, you can see on the low level part, there are different sensors and also some data being put across onto the edge. Edge would then transmit usually to the cloud directly. Yeah, but if you want to do something else at the fog computing layer, that's where all your data analytics come in. That's all your decentralized kind of decision maybe you need to make, autonomous way. And also some of the what you call optimization, if you want to make it, because that part, I think that part actually we can summarize that in the later part. I will talk about why fog, and then why is it the cloud. Yeah, these are the two different things we may also touch. So let's move on. Yeah, so of course we have, because when I'm showing this one, it's basically what we are trying to show. Maybe we just jump across directly to the demonstration today. Maybe for some of you some of the partners or some of the friends, he actually told me, hey, I come to hear your this live is actually I want to see your demo. So let's play the demo for you today first, no problem. Yeah. So Kenneth, maybe you want to take over and then you explain this part.
Okay. So for today over here, we'll show you the edge computing at this site first. So here we have two applications over here. The first one, this one is a power meter, where it's measuring the power consumption, the voltage, the current of this system. And then this one, we have a vibration sensor. So it's putting on the CPU fan. So we haven't turned on the fan yet, because once we turn on, it's become very noisy here. So these two type of data is being sent to we have the vibration sensor data and the data from the power meter. It's sent to this IoT gateway. So we have a
so this one is part of the edge.
Yes, this part is the edge. Yeah. So the edge is doing some Modbus pooling through the Modbus TCP. So, or through the Modbus RTU. Then the next part is if you want to send to the fog computing. So actually we have another server PC in our office. So it will send the data to the server there. So inside the server we have a SCADA software running to do some display, to showing some value,
data manipulation,
and do some calculation, because some raw value we need to do some division or multiplication somehow, some sort of thing like that, and then only we display on the dashboard. Yeah. So okay, maybe we switch to the dashboard.
Okay. Before that, we switch to the dashboard, meaning you are going to transfer to the 𝐼𝐴𝐽 side, is it?
Yes.
Okay. So maybe we get ready. Before we jump into that, this demonstration is being shown as one of your predictive maintenance AI and machine learning for power and also for this vibration analysis. Yeah. So in fact, if you really want to do this part on the SCADA level, you can have a plug-in so-called insight. Yeah. Some kind of AI insight. So that part is, the engine itself is able to perform some kind of data analytic where it can do some abnormality detection. Previously, I think we showed in one of the box before. Yeah. So this part, it can be in the SCADA level. As I told you, on the SCADA platform, it can be one of the top fog computing layer where if you follow our last what they call the session, we have this SCADA publishing data directly to the cloud.
Yes.
Yeah. So right now we are trying to show is how this SCADA level on the SCADA platform is able to act as a fog computing layer for you to do some data manipulation and also data analytics. Yeah, let's move on.
Okay, so this one is the dashboard of the SCADA. So now it's showing the live value getting from this side. So we have on the left hand side is the value from the vibration sensor. We have the X acceleration, Y acceleration, Z acceleration. This one is all because the sensor provides 3 axes. So we have acceleration, velocity, amplitude. Actually, there's a lot more. So we only show 9 of them.
These are all live data, right?
Yes.
These are all live data.
And then on the right hand side is some parameter from the power meter. So we have the power factor, voltage, current, power consumption, all these things.
Okay.
So with all these value, actually you can use it to perform some AI analytics, for example, the abnormality detection, and it's also very useful for the predictive maintenance in the future.
Okay. This morning I've just visited one of our partners. So they were working on some pumping station, in terms of this predictive maintenance. How can they use this part to perform their predictive maintenance? Of course, for those of you who haven't come across this predictive maintenance, what is the main difference between the preventive maintenance and the predictive maintenance?
Preventive maintenance means you do a scheduled maintenance. So maybe every 1 month you carry out the maintenance. But for predictive maintenance, you require a AI to tell you when you need to start to carry out the maintenance. Depends on the sensor data.
So of course you can see the difference is one of the preventive maintenance, you are doing scheduling, and then for the predictive maintenance, you are actually data driven. Data driven meaning you are driven by the data when to perform the maintenance. That's supposed to be more efficient or effective in a sense of cost, time or effort that you are putting in. Yeah. So that one. So maybe we just can we show my slide again? Yeah. This is basically what thing is being connected. Maybe Kenan, you want to explain in this slide. Vibration, sensor, and then we have this power meter, and then also you have other IoT sensor also if you need. By using the Axiomtek Edge gateway, that is an Edge platform that you can collect. So Edge, you may be having a multiple, you can have 4 Edge in a different zone doing this different thing. And also when you go up one level, you can have, just now we were showing the Alistra SCADA platform, which allow you to do visualization of the data logging, even data analytic for this kind of predictive maintenance thing. And then some of the pre-scheduled notification can be escalated from the SCADA level. Yeah, it can be escalated by email or even by what they call the WhatsApp or even by SMS. Yeah. So at this level, at this level, you can also same thing publish to the cloud. I think last week we have done that, so we didn't show that part. Yeah, we didn't show that part. Is there anything that Amir can show?
We didn't prepare for that part.
Yeah, so last week we already done that, so we didn't do. So the bottom part, the AI GPU station is Axiomtek used to have the what they call the GPU workstation, which come with 3 PCIe by 16. You can practically put up a 3 GPU inside. Actually, we have one that having 2 GPU plug-in, exactly the same platform. That one is for us to do some experimental thing, especially on the AI analytics. Yeah. So in future, we are going to show you more. We have what it call. We are working on one of the LLM model. We are connecting Intel. To see whether we can do that part for you. So that is the whole architecture of from the IoT sensors to the edge level, and then to the fog computing before going to the cloud. But what the heck is fog? Why do we need fog? Why do we need fog? If publish to the cloud enough already, what for you? You 多此一举. You want one layer to do. What is the problem? What is the problem of you putting more thing at a different layer? Yeah. Of course, they are needs lah. Yeah. You have that kind of needs to do that. So let's see. Let's talk about why do we need a fog? Okay, why do you think we need a fog in this area?
why we need a fog? We can have a backup of our data. Is that we backup
data
on the cloud?
Yeah, that is very true. So, okay, let's compare first. What is the difference between cloud and the fog computing? What is cloud computing? Of course, cloud computing very far away. Very far away. Like fog computing is just within our premise. Although it's a decentralized kind of server, but it is also distributed. It can be plugged at anywhere, but it's near us. So in terms of latency, because in the whole planning of the IoT architecture, normally, we are very concerned about the latency. How real time. So that is the main difference in terms of latency. Fog computing can give you a more immediate or more real-time process, which most of the data analytics or AI, machine learning, and so on. So you need that kind of processing power to make certain decisions within the layer or within your zone or within your manufacturing plant or whatever. Yeah. So, but cloud computing is, although it's very far away, yeah, but you are able to publish data very efficiently. But then when you want to expect some decision to come back to you, basically cloud is more centralized. So all the thing is going to one place. So in order for them to process and come back to you, let's say come back to you in 3 seconds, but in the fog computing, with a lower latency, can give you within a second. That is the main difference about the latency part, in terms of that. So in terms of bandwidth, yeah, because you talk about, we discussed about this kind of data communication. Data bandwidth is most important. What do you expect? What kind of experience, with our clients? Sometimes they publish to this our AIoT 𝐼𝐸𝐻 Connect Cloud. Of course, you need a very good internet access,
The internet must be stable.
Yeah, you need a good bandwidth to publish your data and so on. But in the fog computing, fog computing do not need, because it's basically within your premise. Yeah, within your premise and within your compound, and that's why the bandwidth requirement in terms of fog computing is much lower than what you're expecting from to communicate to the cloud layer. Okay, that is the some of the main difference. Of course, in terms of scalability, which one do you think, scalability, which one is able to scale more scalable?
For me, almost the same.
Yeah, almost the same. But cloud, good thing about cloud is because your resources, you just subscribe, you just pay, and then you can have, immediately, almost immediate. For computing, you go by station. You want to build another station, you need to wait maybe 1 or 2 days later, I expand another station for you. All right. In terms of scalability, speed-wise, cloud is very fast, but then in terms of this, in terms of scalability, for that, minus of the time, I think both of them almost the same, right? So that's where how you plug in the hardware. Because the main thing is the hardware. What about the reliability?
This one, I think most of the cloud provider, they have can guarantee that almost no downtime.
Availability, available, So you plug in the data center, people is looking after that. But for computing in your company, if you have a very dedicated team to watch them, I think it's almost the same now. You can have that kind of availability. Of course, I would say cloud computing still having a good availability because they all are properly managed in the data center and so on. This is one part. Yeah. So these are the different. These are the different. That's why there are advantages, disadvantages, in this kind of implementation. place where you want to use is you have to determine or you to tailor to your needs. Yeah. So for those of you who still, this is the first time watching this Let's Sembang AIoT. My name is Cecily and 𝐼𝐚𝐲. We are doing this regularly on Friday, 4 o'clock with you, sharing about technology and how you apply in different industry. For example, for this case, we are going to go on for the smart manufacturing side for some time. Yeah. So we talk about IoT, AI application, and so on. Some of the topology, some of the standardization that we need to apply. For example, in the very last case about the fog computing and the cloud computing, the most concerned people are the privacy and security. What do you think? If let's say you are the manufacturer, you are running this one, I want to gather this data, I want to do optimization, I want to do predictive maintenance. Which one do you choose?
Yeah, I would choose fog computing.
You should. Why you should choose fog? You tell me the reason.
Sometimes we have some very sensitive data. When we upload to the cloud, no one can guarantee we still have the control on those data.
Okay. Until the international data space standardization is being put in place,
yes.
You have a full authority in your data set or what they call the data sovereignty. That part, is assured. Then you go for the cloud computing. Yeah. But I think generally there is no right or wrong. It's all depending on the situation that you are in, especially in your process. We don't know, we don't know. But when we come to see which are the things that more concern you, yeah. So is that the bandwidth? Is it the latency? Or is it the privacy or data security is more important? Yeah. Of course, within your premise, you won't. Within your promise, you don't have a premise. You don't have what they call a concern of privacy, data, and so on. Right? Yeah. So that is most important part. So okay, what are the example? Can you list some of the example of fog computing in the smart manufacturing?
Example of fog computing.
Of course, we have just mentioned about this one.
Yeah, that's why we just have a SCADA.
We have just a SCADA, and then we have a predictive maintenance thing, going on. So these are the area where some example of this predictive maintenance. Yeah, predictive maintenance. Predictive maintenance. So it can be sitting on the fog layer. So can predictive maintenance sit on the cloud?
Can.
Yeah, you
actually
can.
No problem, because that one we don't need very real time. Yeah. We don't need to make a very real time decision.
Okay. What about last time? We talked about some smart city. Which are the example of smart city especially for the fog computing? Can smart traffic become one part of fog computing as well?
Yes.
If I'm having a device, or if I'm having a fog node staying together with this traffic junction, are we able to do that as one of part of the fog computing?
Yeah. Yes.
All the decisions, these are all decentralized. You may have 100 traffic lights, but you have a different fog nodes, we call it. These are the area where you can apply some of the industrial PC, like what we have here, Axiomtek have. So that thing can be a kind of fog computing for you to do the smart traffic part. Yeah. So this is one of them. Of course, the last one, the agriculture. Smart agriculture. I think you're supposed the same lah. The same.
You just collect all the sensor data.
You park irrigation system. Irrigation is there's one of our clients. They do smart agriculture by using the watering of the what they call the plant or their crops. Yeah, they do watering, in a very precise way. Yeah, And they also they have this fertigation. They mix the what they call what is called failure is what fertilizer. Okay, that fertilizer, you know, you mix together, and then you do the this fertigation plus the irrigation, you know, watering the thing. These are also can be performed by the fog computing layer. So fog computing looks like it's very practical, you know, it's very
since I already applied it.
yeah. Some of you already you apply it, but you don't call it fog. What fog? It's a PC lah. Okay, so of course, in the terminology of the whole IoT ecosystem, we are very particular about how you park your thing. So it's easier for us to talk, you know, different layer. Yeah. So that I think will sum up the whole thing about the fog computing in this, especially we are targeting the smart manufacturing people. If you do have some of the requirement, you know, or you want to standardize your system, or you want to standardize your system architecture and so on, do talk to us. You know, if let's say we have those things, we are able to share with you, and then we can learn or we can talk more about IoT and AI also as well. So that's come to almost the end of our this session. Is there? Do you have any other thing to share? You know? No. So if no more, then I would want to end with this Sembang bukan seberang Sembang, you know.
Kita Sembang technology.
Kita Sembang AIoT. So thank you very much for watching. So wish you a nice weekend, and we will see you in the next session. Thank you. Bye bye.